This is the Eddystone 830, a high-quality valve communications receiver from the 1960s. Like a couple of other receivers I have, these were seriously expensive when new, so most were used by government bodies and radio enthusiasts could only dream about them. Now, 50 years later, you can find them in online auctions at reasonably affordable prices. So here's my view of the Eddystone 830. If this video is interesting, let me know and I'll have a go at doing the same for my Rakel sets. So, starting at the front, the radio looks conventional with a linear frequency scale. What is interesting though is the dial directly calibrated in kilohertz, tuned by the incremental tuning knob. Now we'll look at this and the other controls in detail later on. So looking at the rear of the set, has an IEC mains connector, which is a modern addition to the set. Next is the mains fuse and a multi-way socket for utility power supply. In the middle is an earthing bolt and the SO239 UHF socket for the antenna. And then finally on the right hand side is another multi-way socket which provides loudspeaker, line and AGC outputs. And there's also an output socket for panoramic adapters and other uses. And finally there's a preset port for S-meter adjustment. Because there isn't an internal speaker, you have to connect a loudspeaker via the multi-pin plug that we saw on the rear. I'll finish connecting that now and we can switch on. There are 9 bands covering 300 kHz to 30 MHz and they're switched using this large control. I'll select medium wave broadcast band first. Note the tuning is very smooth with a classic Eddystone flywheel motion. The reason for such a large band switch control on the front panel is to reduce the effort to switch all the tune circuits involved in a professional grade 9-band set. This is the underneath of the set with the covers removed. So here's the band switch shaft which comes from the front of the set. It operates 9 switch wafers and each wafer has 9 ways. These wafers select the individual tune circuit for each band in each stage of the front end, and these stages are the antenna and RF stage, the mixer and the first oscillator. Here's a block diagram of the receiver, so let's see how it works. The red line shows the general signal path from antenna on the left to speaker on the right. Here is the main tuning control, setting the frequency of the first oscillator for each band. Optionally, up to 8 crystals can be installed for fixed frequency use, although as we'll see later, even using crystals, the 830 can tune a 200 kHz band around the sensor crystal frequency. This is the crystal selector switch. It's not used here as I've no crystals installed. Now when tuning the 3 low frequency bands, the medium wave bands, the receiver operates with a single frequency conversion to an IF of 100 kHz. The second mixer is bypassed. However, when we switch to shortwave, the second mixer comes into play and we have a dual conversion with the first IF frequency in the range 1150 to 1350 kHz, followed by the second IF, which is the common IF with medium wave bands at 100 kHz. So let's switch to shortwave, the 40 meter outer band, and tune some SSB transmissions. The 830 cases for single sideband reception with switched upper and lower sideband settings. I'll select LSB. The switch correctly aligns the BFO relative to the intermediate frequency. I can also increase selectivity by changing from AM to SSB bandwidth. And because we are on shortwave, we can use the incremental tuning control for fine adjustments. There is an internal crystal calibrator which I switch on here. It mutes the incoming signal so you can hear it clearly, remembering to turn off the BFO, which can give a misleading signal. Now here I'm calibrating to 7.1 MHz and the scale cursor is adjusted to give precise calibration. Once calibrated, switch off the calibrator, returns to normal reception. Incremental tuning gives a band spread of 100 kHz either side of the main dial frequency. The black scale shows tuning below and the red shows tuning above the centre scale frequency. In this case, that gives us a range from 7.0 to 7.2 megahertz. Incremental tuning gives frequency setting to 1 kilohertz, which was a rare facility in pre-synthesizer days. Because using incremental tuning takes you away from the frequency set by the main tuning control, the front-end tuned circuits have to be repeat as you increase the increment. The peak RF control does this from the front panel. And as we've been listening to SSB signals, I should point out that the 830 uses a proper product detector with the BFO for good SSB handling. And also the BFO control itself, it tunes only a 200 Hz range in SSB mode, so it can be used as a clarifier. In CW mode, the BFO has its full frequency span of 6 kHz. Selectivity is adjustable by using a movable coupling in the 3 IF transformers controlled by this lever. It has click stops for each setting, AM, SSB and CW, but it's also continuously variable. Here's a Morse signal. It's been pulled out of the clutter as the bandwidth is reduced, and then finally a crystal filter is activated as the switch reaches the end of its travel. As selectivity is set back to the wide AM setting, all the band clutter returns. This is one of the IF transformers with a cover removed, showing the primary and secondary coils close together. This is overcoupling, and it gives the broad AM bandwidth of 6 kHz measured at -6 dB. In the SSB position of the switch, the coils are moved apart to reduce the coupling to a position where a 3 kHz bandwidth is achieved. And then in the CW position, the coils are wide apart, giving a 1.3 kHz bandwidth. There is a final position to the selectivity control, labelled N, and that switches in a 50 Hz wide CW crystal filter, and that gives the maximum selectivity for Morse and digital type transmissions. Well, I hope you found this interesting, and if not, at least you know what the Eddystone 830 is all about. Thanks for watching.